Over the holidays I threw together this diamond grinding and lapping machine. In this video I want to go over the construction and the discs. If you're not familiar, the purpose of this machine is to shape and polish parts made from very hard materials like tungsten carbide or ceramics and achieve very clean, sharp edges. The machine will also work on softer materials, but that's not really what it's intended for. Here are some lathe tools I've already finished with this machine. They are a steel body with a broken end mill shank silver brazed into them. I have a diamond cutoff wheel for the D-bit grinder with which I can grind the rough shape of these tools in very quickly. From there I can refine the geometry and surface quality on the lapping machine. The two main drive components, motor and planetary reducer, I got from AliExpress. The motor came included with speed control box and plugs straight into a 220 volt outlet. On the side it's called a permanent magnet servo brushless motor, 550 watt model, and I got it for €106. The planetary speed reducer is called an SPLF60 low noise planetary gear reducer, model 10:1 for 14mm servo, and I paid €46. If you get these exact same components, I recommend going into the parameters of the motor controller and turning on the electronic brake. That makes reversing the motor a lot quicker. I did have to take the motor shaft out of the motor to turn down the end to fit the planetary reducer. Maybe there are other reducers that fit straight away, but I couldn't find one. The motor came with an Australian power cord, so I did change that out for one that will fit my local outlets. I made this machine on the fly with no design, no drawings pre-made, straight stock rack engineering. The most critical component is the plate that joins the motor and reducer. Misalignment between the motor and the reducer shafts can cause short-term bearing damage because there is no soft coupling between these components. I took the chance and made the drivetrain as compact as possible. We'll see how long it lasts. This motor does 250 to 7000 RPM. That means through the reducer we get 25 to 700 RPM. I found that to be an acceptable speed range for diamond grinding and lapping. When I'm using solvents on the plates, I usually don't go above 500 RPM because it will just sling the majority off the plate. The table needs to tilt in positive and negative angles and has to be large enough to support the work, especially on the sides. In hindsight, I would have made the table a little bit wider, but it works. The table is suspended on two 4mm pins through reamed holes and held in positions by a single linkage bar. The fit is so tight that when I lock the screw, there is no play in the system. The flat bar construction was milled, drilled and tapped. There are no special features for alignment, just generous clearance holes for the screws. The two hinge pin bores align themselves when assembled. Placing 3 rubber feet under the machine stops it from skating across the bench when using it while grinding. I'll be gluing those in place at some point. The disc mounting system I borrowed from Stefan Gotteswinter, so major credit to him. It's basically magnets, a central register diameter, and one drive pin to transmit torque. The holes and pins have some clearance, so there is some play which helps quicker installation and removal. The diamond discs come with a central hole and just need an extra hole drilled. These discs are 100mm in diameter and I have them from 600 to 3000 grit. Now the main reason why people make machines like this is to use ceramic discs in combination with diamond paste or slurry to achieve super sharp and clean finishes on materials like carbide and CBN. The discs are aluminum oxide, sold as lids to crucibles for casting precious metals. They are way too rough to use for lapping like this, so first we need to smooth out one side of the plate. I just use the wheel for the grinding machine attached to a drill. I found that isopropyl alcohol as cutting fluid works very well to smooth this down. WD-40 also works, but for some reason it cuts a lot slower. The reason why this plate needs to be ceramic is that when you are pushing a cutting edge into it, the tool should not be cutting into the disc. It needs to be harder or at least a similar hardness to the tool. So I literally put this wheel hub on a shaft in my electric drill, put the ceramic plate on a rubber mat, put the drill on it, pull the trigger and grind away until the whole surface is smooth. Now with one side rough and one side smooth, we need to glue a steel backing plate to the rough side of the ceramic disc to be able to mount it on the magnets. For this I use metal filled epoxy. Regular epoxy probably also works fine. After the epoxy has cured, I chuck the plate up in the lathe, face the back parallel with the front, and drill the necessary holes. And just like that, we have a ceramic plate on the lapping machine. To check if the whole surface is smooth, you can use a regular graphite pencil and feel where it's smooth or still rough. Some people make this kind of lapping machine from salvaged industrial equipment, and that's great if you can find it, but I think the beauty of this drivetrain is that it's just off-the-shelf components you can buy right now. It's a bit unfortunate that it's through AliExpress, but I wasn't able to find local sources for this kind of configuration anywhere near that price. Maybe it's possible to find a combination of motor and gearbox that doesn't need the motor shaft modified, but you'll need a lathe anyway to make the disc carrier. I'd like to do a follow-up video sometime and get into more detail about making the tools like silver brazing and rough grinding on the D-bit grinder and the different diamond pastes. I've also bought some solid CBN inserts to braze onto tool shanks and try my hand at some homebrew hard turning. If that sounds interesting, stick around and I'll get to it.